Okay, so now we got population standard deviation. So before it was sample standard deviation, now we're talking about population. Population standard deviation. Okay? So, what we're talking about here is the difference between x bar, which is sample, and mu, which is population. So even though we found the means, remember we found the means and they were the same thing, they equal each other, they're the same thing, well, the means equal each other, but once you start dealing with sample standard deviation, which is little s, and population standard deviation, now they don't equal each other. Okay, they're close, but not quite. So we have this little, it's little sigma, okay? And so remember, big sigma is this guy, right? Little sigma is this guy. And little sigma equals the square root of the sum of the x squares divided by the n, and we use big N. But big N, cool thing is they use little n, and here we use big N.
They both do the same thing, right?
They're the same thing. Minus mu squared. So now we're going to start using the stuff that we found earlier. Okay? Okay, so we need to know some things. We need to know
EX squared equals 230.
EX squared. We also need to know mu, and we need to know what n is. That's the things from this thing, right? So we need to know this, we need to know this, and we need to know this. Cool part is
EX squared equals 230.
problem number 1, we found this to be 7.
Yeah.
Right? Or problem number 2, sorry, problem number 2, we found that to be 7. Okay?
Mu.
Right? So mu is 7. But what we need is mu squared,
49.
which is 49. Okay? Alright, so that's not bad. So we found one of them already.
EX
Then we need to know what n is. Well, remember, n, I'll do this in green.
4 minus 1.
No. N was 4.
Yeah.
Yeah. So now what we need to know, oh, well, then that's just 4. So we know 2 of them. Oh, snaps. In the last equation, we used the same data, remember?
Yeah.
Oh, we found this. We found this, sorry. And we found it to be, and I'll do it in blue, 230. Because remember, now we have all our numbers, but what did we start with? So we have to, let me reference this. X was equal to 3, 6, 8, and 11. Okay? So what's really nice is changing this pen for this one. Hopefully it writes better. What's really nice to do is, so, okay, I'm going to make my x's. Okay? I'm going to make my x squares. Okay? So, my x's are 3, 6, 8, and 11.
9, 36, 64.
So my x squares are 9, 36, 64, and 121. Good. Okay? What else do I have? So that's my matrix so far, right? What else do I need? Well, we said before that we needed the sum of our x squares. So we can just use that as this box, right?
Yeah.
So our sum of the x squares is 230. And then we said, oh, I could also use the sum of my x's. And that would be 28. Is that right?
Yeah.
And then I also, you know, I could use the sum of my x squares for my last problem.
784.
Sum of my x squares was 784. And so we have pretty much everything we needed. And for this problem, we only needed
X squared.
this, right?
Yeah.
And we needed this, right? And we had to dig way back in our other problem and get this, which was just the mean. In order, and remember, that's just the sum of the x's divided by n, right? So again, the sum of the x's, which is this. So I guess we kind of needed that, but we already found the answer. Okay, so making these matrices is huge. Make this; it helps you, and it'll help you even more when we in later. Probably not in this test, but when we do the third quarter test, it's going to be very helpful. Okay, so that's that. So let's do the actual math. The actual math is that little sigma is equal to the summation, or the radical, or the square root of 230 divided by 4 minus 49. So we take 230 divided by 4, and we get 57.5. So we get 57.5 minus 49. Okay? So minus 49 equals
8.5.
good, 8.5. So the square root of 8.5. Right?
Yeah.
Yeah. So that's our actual answer, right? Now, what we want to do is we could do some funky math, like, okay, change this to find the actual answer not in decimal form, would be like, okay, that's really 8 1/2, so 2 times 8 is 16,
Yeah.
plus 1 would be 17 over 2, right? But we can't have the square root in the bottom, so then we have the square root of 17 over the square root of 2 times the square root of 2 times the square root of 2, so we ended up with 2 times 17 is 34 over 2. So that could also equal the square root of 34 over 2. And if you put both of these in your calculator, you'll find that they equal each other. Totally equal. So what I did was I said, okay, 8.5 was equal to 8 1/2, which is also equal to 17 over 2. Okay? So, and then I had to get rid of the radical in the bottom. So this is what I like to call the real number. You know? That's the real number. Okay? And then what we want to do is we want to find the approximate number, right? So that's when you throw in your calculator 34 square root divided by 2 equals
34 square root.
Equals 2.9154 759. Well, let's see if I did this right. Did I do my math right? So double check yourself. Is 8.5 square rooted the same thing? Oh, it is. So I did my math right. So whether I put this in my calculator and hit equal, or I put this in my calculator and put equal, I get this.
So I go